Good morning, everyone. Welcome to today's webinar. My name is Sophia. I organize events, Spectrum events for you. So for those of you who are new to Spectrum, we are located at Duo Tower. So aside from providing event spaces, bringing the community together through learning at Spectrum, we also offer curated workspaces for the community experience. So we connect members and we offer resources needed to expand your business. So today we are very privileged to have EcoLabs Center for Innovation for Energy to talk about future of transportation, mobility as a service, and urban air mobility. So first up, I have Ryan Jin. So Ryan will start the presentation on the first part to talk about mobility as a service. Ryan leads the Smart City and Future Mobility verticals at EcoLabs Center of Innovation for Energy at NTU Singapore. His current work involves identifying technological and business opportunities, developing partnership prospects, and supporting Singapore startup and SME for technology development and growth. So he also manages the collaboration prospects in the Greater China. So the next part of our presentation will have Dr. Arvind Mutia. He leads the mobility and energy storage at EcoLabs Center for Innovation for Energy. So he is the person responsible for setting up labs and test beds suitable for translation of prototypes in the mobility sector, land, sea, and air, to commercially viable products. So he works on due diligence, technology assessment, road mapping, and scoping of projects for SMEs and startups. So a little bit about EcoLabs Center for Innovation for Energy. So it's established jointly by NTU, Enterprise Singapore, and Sustainable Energy Association of Singapore. So its aim is to help Singapore-based energy startups and SMEs, the essential translation facilities and connections. So without further ado, Ryan, over to you. Thank you.
Hi, thank you, Sophia. Hi, everyone. Can you hear me okay? So I'm going to share my screen now. Just let me know if there's any issue. Okay, so I hope you can see my slides. So I'm Ryan. I'm with the EcoLabs Center of Innovation for Energy, and I'm going to talk about the future of transportation from a mobility as a service perspective. So before I start, just to give a very quick introduction of EcoLabs. So as mentioned, we are a joint initiative between the Nanyang Technological University, Enterprise Singapore, and Sustainable Energy Association of Singapore, SEAS. So the key objective of EcoLabs is to build and accelerate the deep tech energy innovation capability in Singapore. So we do this by two parts. One is on the innovation capability, and the other is on business capability. So we do technological development, test bed, and developing an ecosystem of players and a learning platform. Then on the other hand, we also work on the funding and investment, some of the market entry programs, and co-innovation programs to help the startup to work more closely with from a demand-driven approach with the corporates and the prominent statement owners. So it's really about building the entire energy innovation ecosystem within Singapore with the different players like the startup, the corporate partners, investors, and the wider players, including the government, the research institute, the test bed partners, and so on. So how do we typically collaborate with our partners? If you're corporates or investors or channel partners, we typically run co-innovation programs, deploying test bed solutions, test bed site, and deploying solutions there. If you're investors, we probably could work into co-invest in our startup, in our accelerator program, or some of our co-innovation programs, and to provide the values for the startup and the ecosystem partners. For startup and SME, it's pretty simple. We can run co-innovation program, co-development projects, developing your solutions into market-ready level to evaluate your solutions and deploy in one of our global test bed, and join in our events, activities, and some capability training programs. So I understand some of the quite a bit of the audience are from the investors sector. So maybe I just give a bit more information. So how do we collaborate with investors? Firstly, we do identify the focus area. So with that, we will long list, we do some scouting and long list of the startup based on your focus area, and we can run pitching sessions and conduct due diligence for the investors on behalf. Then at the end, can do facilitate the investments, structure the investments, and so on. So this is how we can work with investors to identify suitable startup companies. So now going into the topic for today about mobility as a service. I always like to start with this set of slides. So how much space do we need to transport 48 people? If in a typical setting, if we need to transport 48 people through cars, this is the amount of space, this amount of vehicles we need. Then it doesn't really matter whether is it internal combustion engine vehicles, electric cars, or even autonomous vehicles. But what would really be more efficient is really look at mass transport options like buses or trains, where it's more efficient to transport 48 people or 48 or even more people at a single go. I do know that there are many people who are also promoting cycling as a one way of transport, and it does reduce the space required. But what I also want to share is that taking bus, mass transit, or even bicycle may not be suitable for everyone for every trip. So it's really important to really relook at the purpose of the trip and how do we provide a more customized, more user-centric transport options. So the problem about urban mobility is really in these four areas is urbanization. We are looking at increased density. By 2030, it's predicted that more than 1 billion more people will live in cities, and by 2050, more than 80% of the world populations will live in an urban environment. There are competing use of land. Some places, new infrastructure is not possible. In terms of pollutions, global emission from mobility is expected to double by 2050. We are also looking at personal vehicles, probably will account to 70% of these mobility emissions and cause more than 50% of the city's air pollution. When we transit from internal combustion engine vehicles to electric vehicles, we are also facing the uncertainties around the end of life of batteries, the maintenance issue of out-of-warranty vehicles and disposal and so on. So these are some of the problems. And on the safety side, urban areas are looking at more than 50% of the traffic fatality. And the whole space on safety, what actually means that driving motorcyclists is actually more dangerous than people who are commuting on rails, on planes, or even on bus. We also know that putting more vehicles on the road will only cause more congestion. In Europe, for example, it costs about 1% of the GDP due from congestion problem. And congestion is always a demand management problem because everybody wants to go to the same place, go to the workplace in the morning peak hours, and the evening peak hours, everybody moving out from the urban space. Then there's also another issues of the uncoordinated deployment of new form of mobility. So we have seen over the last few years the rise of the shared bicycle, shared e-scooters in Singapore, and so also some of the other shared form of mobility solutions. So this unplanned, uncoordinated deployment actually causes more congestion and issues for the different players in the urban environment. So after talking about so much about the problems, issues on urban mobility, what exactly is mobility as a service? I'm just taking some quotes from different players. MaaS Alliance actually defined as an integration of various forms of transport services into a single mobility service accessible on demand. MaaS Global, probably the first MaaS service provider, quote them, bring all means of travel to one place, easily accessed through a smartphone anytime, anywhere. And the UCL Master Lab actually define it more clearly. And something that I believe I'm more aligned with is user-centric, intelligent mobility management and distribution system. So it is a integrator to bring multiple mobility services through a digital interface and allow them to be seamlessly planned and paid for mobility. So this is something that I thought is quite interesting. So essentially, MaaS actually bring integration, bring different type of mobility. It has to be a user-centric experience for everyone, and really to provide them as a service. So it to give it a bit more clear definition of what it means for the user. The current situation now, when we want to book a taxi, when we're going to take a bus, a train, or even take a flight, we are going through different applications, different sales channel, and different payment modes. So this means that probably if it's on your phone, you probably have at least 5 or 6 transport related app on your phone, and even for something that's more traditional like booking airline ticket or ferry ticket, sometimes you have to do it on a separate platform, going down to the ferry terminal to book a ferry ticket. But what MaaS is trying to do is to bring all forms of transport and mobility services into a single app. So from the user perspective, you do not need to face a different application or sales channel. You can do all transport planning matters through one MaaS app. And the integration will actually give a much more user-friendly experience to deal with the transport experience. So what's important for a MaaS deployment? I borrowed these slides from the Finnish transport agency. So at the first layer, you need to have your infrastructure. So that's your roads, your rails, your airport, and so on. You definitely need to have the infrastructure for telecommunication and information infrastructure. So that's where your mobile network is. That's where your network to bring in the other international information and so on come in. Then we also talk about interoperability, where the different services can actually be coming through in the same platform. So it could be standards, it could be a communication protocol. That one level up when we have intelligent traffic infrastructure. So we talk about the traffic management system. How do we pull and push data, digital ticketing? How do we enable user to purchase ticket, not from the counter, to do it digitally, to purchase the seats, the ticket, and everything. The routing services is the transport solution. It's flexible enough to do different routing, dynamic routing, on-demand solutions, and so on. Then at the service side, how do the MaaS operator or transport operator integrate these online services and interface together? So the society, the transport players need to have open data. They need to have interface and API enabled, and all this probably need to be on cloud service as well. And we need to have sensors or Internet of Things sensors in different locations. So for example, in the vehicles, in the bus in Singapore, we have a crowdedness indication. We know that the bus is at a certain level of crowd. So the MaaS solution to the app needs to be able to be intelligent enough to understand whether the user could board this vehicle at this time. So at the integration level, at the top level, then we talk about mobility as a service. So that's where different operators can actually provide customized services, bring different mode of transport into single user interface to provide other additional services. So if you're familiar with the mobility as a service, sometimes it has, at the start, people like to say it's a Netflix for transportation, where you provide a subscription model for all your transport requirements. So going through such details, the MaaS market is actually very interesting. we are predicting over the next couple of years to have a 35% growth. Sorry for this. And the year-over-year growth rate for 2019 is about 33%. Just within APAC region, it contributes to about 44% of the growth. So these are some of the interesting data and market opportunity for MaaS within this region. And right now it's still fairly fragmented, and the players are actually occupying different market shares and so on. So there's still a lot of opportunity in this area. So how might MaaS change urban mobility? This is a illustration of a future living environment in Singapore, in Tengah. So the philosophy in this is that, in moving forward, the urban design will be more integrated, mixed use. It's unlike in the past, we have one CBD area and we have the residential area. So this will actually cause more transport need between residential to office workspace and so on. So that's where congestion and transport experience were affected. But with a more mixed-use environment, most of the spaces where you need to be, from your residential to your office to the MNC, the grocery, shopping malls, and so on, will be fairly within reach, maybe within a 2-kilometer reach. So that's where your transportation needs could be largely filled up with walking, cycling, or even on-demand shuttles. So that's where a mobility as a service app will be very useful. We can talk about using the public transport as a backbone to move people from places to places. And while you reach the destination, the stations or near the destination, you can actually call for on-demand shuttle, or even pick up a shared bicycle or shared e-scooters along the way. That will be ready for you to pick up when you arrive there, and for you to continue to your last mile journey. So there's a question mark here, and I really like to explore the thoughts on urban air mobility that Dr. Arvind will actually share about. Could we have drones, passenger-carrying drones, flying around this area to pick up passengers so that it can bring me from one end of the country to another end of the country? So I think this is something very exciting where MaaS can really change the behavior and transport pattern of the urban mobility. And what does MaaS mean for consumers and cities and even mobility service providers? I think for most of us, for consumer, you definitely will have a more personalized service. Your commute experience will be better because you will know exactly when you need to get where. You can choose how much you are willing to pay, how much time you need to you are willing to spend for this transport. And there will be transparency for your costs, your carbon emissions, and your transport experience. And the service will be integrated. You don't need to open 3 apps to check what's the best way for you to commute from point A to point B. You don't need to open a journey planning app to plan your journey, go through the different app or for payments, for locking or unlocking of the different mobility services like a shared car or a shared bicycle. The subscription model could also mean that there will be more cost saving for you as a consumer. For the cities, it reduces congestion, it reduces pollution because of better optimized and journey planning. It will enable the cities to optimize the maintenance of the infrastructure, and it creates data-driven services where the urban planner could use the data to even improve on the city planning, and it definitely improve on traffic management where you have less personal vehicle on the ground. For mobility and even other service provider, you definitely improve on your customer experience. It will be easier to manage and operate your fleet. There will be improvement on the infrastructure, the operation, and the customer retention. I include other service provider really coming in from the angle where mobility service is not just about mobility. There are other opportunity for other players, for logistic companies. Could the vehicles ferry goods in addition to people? We can talk more about it later. Could a vehicle be used for e-commerce logistic delivery? Could it be used for other purpose? So that's something that we may not need to differentiate people mover and goods mover anymore in the future. I will get to that point later. So for future of MaaS, it's definitely about sustainable mobility. It's cleaner, safer, and definitely more efficient. It needs to be smart. We are talking about connected and telematics on top of autonomous vehicles and commingled mobility, which is something that I really like to talk about, where you can move goods and people in a adaptive way. So this video is actually from Toyota. Their vision is actually an autonomous vehicle that can ferry people and goods at the same time. So this is on a on-demand shared basis where nobody needs to own a personal vehicle. The autonomous vehicle will be on the ground all time, and when there are needs to move people, they will actually you just book through the app. You can put on the autonomous vehicle. It will at the same time also optimize the area and pick up goods and deliver goods at the same time. So I think this is one of the way I envision the future of urban mobility, where it's very dynamic, it's very flexible, and the vehicles are no longer a single-use vehicle. It will improve the optimize and utilization rate for the different type of vehicles. So now I want to talk about two case studies of a Singapore local startup working on mobility as a service. So the first one is Zipster. It's a local startup doing MaaS applications. They already implement the Zipster app. Sorry, the company is called Mobility X, and they already deployed the Zipster app in Singapore. So what they do is that they actually bring in the journey planning, the payment, and some of the multimodal options within the Zipster app, and at the same time providing insurance coverage for the commuter. So they integrated the journey planning from function from public transport, even Grab, shared bicycle, shared vehicles, and so on. And through the app, you can actually access the different options and seamlessly make the payment via a Zipster card to all the different public transport. So the payment will be integrated back to the app. It allows multimodal, customizable route options. There will be indication of whether the bus is crowded or not. You can actually purchase vouchers in the marketplace, where is it be it for Grab food or e-commerce or shared vehicles and so on. Then they also recommend the places that you are that around where you would like any interesting food places, any interesting places to recommend to go. So this actually tie in another business model to improve the consumptions purchasing in that area. So there's another angle in the e-commerce, the advertisement side. Another startup is Rush Hour. So they introduced an on-demand public transport network for smart cities. It's a Rush mobile app. So what they do is that they actually do an on-demand mobility service for people moving from residential to their workplace where it's not accessible. So they do dynamic routing, on-demand, and online ticketing and reservation, and it will guarantee you a seat if the booking is confirmed. So they utilize the AI dynamic routing algorithm to optimize the fleet resources and to match the demand. So imagine if you have many routing requirements through their app, they can actually do a optimization of their routing and utilize the vehicle assets around the area. So this will allow them to really, as a city as a whole, to optimize the asset and the demand matching. So I'll skip a few of these details. So what I really want to talk about is that there are mobility as a service, as a concept, there are a lot of opportunities within it. And the existing transportation system, definitely pre-COVID, we are experiencing during COVID pandemic, we are experiencing reduced transport needs. But as we progress to a new norm, even getting out of this COVID pandemic in the post-COVID world, the mobility requirements will definitely recover. It will go back. And mobility as a service is already moving forward, will be an opportunity to optimize and improve the experience and even the profitability for all the players in the mobility sector. And it is still a fairly fragmented and open space, and we uh, we are looking forward to more exciting technology players to come into this field. So in EcoLabs, we are also working with Continental on the EcoLabs Continental Urban Mobility Accelerator Program, what we call the ECOMA. So that's where we want to work with SME and startup to co-create solutions in the future mobility sectors together with Continental in areas like autonomous vehicle, autonomous area mobility, electric, telematics, and intelligence. So that's where we will provide up to 125,000 Singapore dollars in project fundings and startup support to the startup to deploy their solution in one of our testbed sites, ideally in Singapore right now. So this is quite interesting for startups and technology provider who wants to get their solutions deployed on ground. All right, that's all for me. If you have any questions, you drop me an email at ryangin@ntu.edu.sg. Otherwise, you can follow us on the EcoLab website and LinkedIn site for more information. Right, thank you.
Thank you, Ryan. So Ryan, if you don't mind, can I welcome you to stop your video? And then let me welcome Dr. Aravind Mutia to talk more about the urban air mobility. So audience, if you have any questions during this time, feel free to post them on the Q&A platform. So without further ado, Dr. Aravind, please, over to you.
Yes, sure. Thank you.
Yeah.
Okay, good morning to everyone. I hope you're able to see my presentation now. And if there's any problems, to let me know, even in terms of hearing or the video itself. Thank you for everyone to attend this talk. And my teammate Ryan has already given an overview of what we do at EcoLabs. I would delve into the urban air mobility sector, which basically consists of what we all usually dream of as kids: flying cars, flying taxis, and how it might impact the future and how far away we are to realizing those kind of technologies. My slides, I have around 20 slides. I'll take around 20 minutes to wrap them up, and then please do feel free to ask any questions that you may have. So just a bit of background about myself before I start. Sophia has already introduced me. I'm part of the EcoLabs team leading the mobility sector, mobility vertical along with Ryan. I focus on more on land, sea, and air mobility, so electric vehicles, autonomous vehicles, ships, and also, in this case, aerial vehicles for urban environments. The work I do is mainly mainly on the technical side as well as the road mapping side, and how we can further the technology development in these areas. So to get started, I'll probably first define what urban air mobility means, because people might be confused, as it means different things to different people from different parts of the world. The way we look at it is it's a form of passenger or cargo transportation, and within a city or metropolitan environment. And the core aim is here to highly automate them and make them highly efficient. So with this as the underlying theme, I have 5 segments to my presentation today. The first 4 would focus on larger urban air mobility vehicles, such as air taxis, while the last segment on Sampa Drone Labs would focus on what currently is viable in the drone sector and how EcoLabs is supporting that sector. So let me get started with the trends in the urban mobility side itself. So as you can see here, uh, the, the urban air mobility world over globally is classified into intracity and intercity. And under intracity, you have airport shuttles, air taxis, air commuters, and regional air travel. So this is primarily for passenger movers that this sort of classification is there. Uh, and the sort of timelines we are looking at is that in 2030 or so, we expect these intracity airport shuttles to play a big role or come about. So this is a decade of these airport shuttles to really start bearing fruit. And later on, we would start seeing intracity and intercity solutions as well. Intercity air taxis as well as intercity solutions. So the plot here is slightly low on resolution, so you're not able to see the different cities that have been mentioned here. It's mentioned a number of cities in the world, but for some odd reason, it hasn't mentioned Singapore. And that's one of the topics I will be touching upon in the next slide. How this global view of UAM boils down to Singapore, and does Singapore share the same sort of vision, or are we looking at different sort of applications? Also, the passenger drones in this sector are expected to ferry over 900,000 passengers by 2050. So the growth will be slow. A lot of restrictions, regulations need to be passed. But as you can see, this is a decade when these sort of solutions really start to take off. So in terms of Singapore, what we mainly see is there are three major drivers for adopting urban air mobility solutions. And these are demography, economy, and land. Demography because of the aging population, economy mainly because of tourism and the huge logistics sector here, as well as the land constraints that Singapore has. So I'll delve into each one of these with a bit of quantitative analysis. So it's expected that 25%, that's 1 in 4 Singaporeans, will be greater than 65 years old, senior citizens by 2030. And that potentially means that you will have 100% increase in the sort of emergency medical calls, meaning you would need emergency response teams to react quicker because of the increase in demography, increase in the age. The second area is on the economy. And here we have two types of factors affecting the economy. The first is the logistics. 17% of the vehicles on Singapore's road currently are logistics related. So with a sort of packed environment like Singapore, you would want lesser and lesser logistic vehicles, or you would try to reduce the number of vehicles on the road. And this is a big sector to look at. Also, these vehicles are all gasoline powered, so they have 50% of all vehicle emissions. And 75% of the cost for transporting freight. The last mile transportation is 75% of the logistics cost. So that's where there is a potential for switching over to a more cleaner, quicker, and less congested solution. And the third, under economy, the other area is in tourism. And here, due to COVID, a lot of these numbers have changed, but based on 2019 numbers and projected to 2030, the expectation was to see around 33 million transit passengers in Changi. And that's one of the reasons that the Jewel was built. You're looking to make these transit passengers spend and grow the economy. So their spending power is estimated at around $1.2 billion. Now, these transit passengers spend around 3 to 4 hours in the airport. And for them to take a conventional form of transport from the airport to the downtown or tourist spots in Singapore and back again would take time. So there is the opportunity to make them spend more in the downtown area, in the tourism spots of Singapore, uh, by using some sort of transport which reduces time for transportation between the airport and the city. And another part of the economy is daily commute times and productivity. So what we see is Japan is one of the lowest in the world in terms of uh, time spent by an average commuter on a daily basis. And it's roughly around 40 minutes. But you can see Singapore here is 80 minutes. It's almost 2 times what you see in Japan. So there's a lot of scope for improvement despite Singapore's uh, quite efficient public transport system. We see this huge gap, and despite Singapore being small, and there again there is the if you manage to quantify the loss in productivity by the time due to the time spent in commute, it can go up to 16% of the GDP of Singapore, which is much lower than the other countries, mainly because Singapore is a city state. It's determined by the city's efficiency, while the other cities here are parts of larger countries where the GDP of that particular city has a much lower impact on the overall GDP. So any improvements in the city's time of commute would again enhance the sort of value of the commute as well as the worker, and that's where there's another economic value. And finally, land is a big constraint in Singapore. 21% increase in population is expected by 2030. So right now we have around 5 million here in Singapore, 5 million residents. It could increase to around 6 million. But that is not supported by a proportional increase in the area for land transport infrastructure. Land transport infrastructure is expected to increase only by 1%. So this land constraint would only exacerbate from the current situation. And it's these three, the economy, land, and demography, which is basic driver for what could be a potential for deployment of urban air mobility solutions in Singapore. So I've summarized those three key problems here and what sort of solutions we could provide. So the first in the demography side is to provide this timely delivery of emergency services and also law enforcement capability and improve reaction times. The second, economy. First, we are looking at logistics support. Second is augment Singapore's tourism status as a tourism hub by enhancing connectivity to the airport, as well as shorten daily travel times for the local population. And finally, we're looking at the transport bottlenecks introduced by a smaller land availability, and this in turn would be alleviated if we use urban air mobility. So with those sort of justifications, I would get into the sort of ecosystem that exists in the urban air mobility sector in the world and some small roles that Singapore is playing so far. So this ecosystem map I have here details the cargo movers, that's basically goods transport, and the sort of companies involved in that. So we have four major types of stakeholders: corporates, local authorities, investors, and enablers. Some of the key enablers here has been post office companies like Swiss Post and corporates like FedEx, UPS, and DHL. This is where Temasek also comes in, which is the Singapore angle. We've invested in Zipline, a company based in Africa for emergency deliveries. But as you can see, there are a number of companies which have started. Kitty Hawk is quite famous and doing trials in New Zealand. But the big players of Airbus and Boeing are also invested in some of these startups. On the passenger mover side, it's it's a more widespread with different types of companies coming into play. So you can immediately see that the sort of companies the sort of companies dealing with UAM have already sectioned themselves into either passenger movers or goods movers, even at this very early stage. So you have Uber as one of the key enablers. They have Elevate conference every year where they detail some of their developments and how they plan to support the urban air mobility or air taxi economy. And of course, you have the technology providers here in Brea Airbus, Bell, who are developing their own solutions as well as working with startups to help them develop the solution. The Singapore angle here is that of EDBI, which has invested in Joby Aviation. And this is touted as a big potential startup in this UAM sector. The, uh, the, the technology challenges that UAM poses are just as important as the regulatory challenges. So uh, uh, the regulatory bodies usually rely on the normal aircraft that we use to go between cities as a benchmark for determining how these air taxis or urban air mobility vehicles should be certified. And hence, the technologies that need to be deployed need to meet that sort of certification and redundancy criteria. So these air taxi or urban air mobility vehicles are of different types. They all usually follow a concept of called DEP or distributed electric propulsion. So many of them are touted to be emission free, and so they're primarily electric powered. But compared to conventional aircraft where you have two engines or one engine, these vehicles split uh, the motors into multiple propulsion systems. Therefore, you have a distributed energy propulsion system. The main reason they do this is to bring in the safety factor and redundancy factor where even if one of the rotors fails, the vehicle doesn't crash. So there are different types under that itself. So you have highly distributed systems, quadcopters, which is very similar to current drones, hybrid concepts which use wings as well as rotors, and tilt wing. Tilt wing uses the set of propellers for takeoff, vertical takeoff, and then the wings with the propellers tilt to move forward like a normal flight. And then you have fixed wing concepts. So these are the kind of like major architectures of urban air mobility systems which are currently available. And from EcoLabs perspective, we are mainly focused on energy. So we look how to power these architectures rather than design our own architectures. What we mainly look at is the other conditions which are required for a viable market. And these are on the safety and security side, our expertise with communication systems, as well as autonomy, how to make these vehicles completely pilotless. Those are the areas that EcoLab supports in. Economics, how do we reduce battery cost? Enable the right sort of charging infrastructure or distribution hubs. Again, this is where EcoLabs is strong. And the demand side and public acceptance, we usually don't get into it too deep, except on the noise side. So one of the key drivers for public acceptance of drones right now is the noise that they make. And as I will show a bit later, we have a test bed which is designed to evaluate noise and benchmark systems on their noise emissions as well. So the key areas that EcoLabs supports on the sort of large urban air mobility vehicles is mainly threefold, and all are related to energy. First is the electric propulsion systems inside the vehicle. The second is charging infrastructure, and the third is autonomous systems, making them fully pilotless. On the electric propulsion system side, we work on battery packs, combining different types of energy storage, fuel cells for hydrogen powered or for hydrogen powered systems or combining them with battery systems, monitoring how these batteries degrade. We have EcoLabs has a lot of expertise on the electric vehicles, ground-based electric vehicle side, and we are trying to bring that to that sort of knowledge and know-how to advance the technology development on the urban air mobility side. And the final side on the electric propulsion systems is next generation batteries. One of the key drivers for electric urban air mobility is that the batteries need to improve their capacity while reducing weight. And that's where we are working on new materials for batteries and newer systems as well. As a side here, Tesla's Battery Day, which this year will be held on September 22nd, is is expected to release a new kind of or showcase a new kind of battery, which is significantly higher capacity. That sort of game-changing technology would enable the urban air mobility solutions of the future. So I would encourage the audience to check the Tesla Battery Day out on September 22nd. The second area is on charging infrastructure. This is quite often very underlooked by a lot of companies in this sector, mainly because most of these air taxis would be landing on top of buildings or on top or in very isolated environments where there is a difficulty in getting electric power. And if these vehicles have to be fast charged before the next takeoff, or have to have technologies like swapping of batteries, you need specialized electric systems. And that is where, again, EcoLabs is supporting on multiple areas. The first is high voltage chargers, solid state transformers, which make these charging systems compact so they can go on rooftops, not only of buildings, but also of houses. Fast charging systems, which we have demonstrated in electric buses here already in NTU, and power management system. So you don't want the entire building to be plunged into darkness when, let's say, a vehicle lands on top of the building and charges. The building's energy load is not designed to cater to that sort of new power draw. And that's where, again, there is some intelligence required in how we design and put in place these systems. This is, again, where EcoLabs supports. The final area where we support is on autonomous systems. We have teams which develop new controller hardware. This is combining different sensors and showcasing their worth or utility. And also navigation and perception algorithms for these vehicles have been demonstrated on land. The objective here is mainly to translate all of this know-how for aerial vehicles. And finally, cybersecurity and managing a fleet of such urban air mobility systems. So that kind of like sums up the first part of the presentation, where I focused on larger systems under urban air mobility. And now I'm delving a bit deeper into smaller systems, which are like drones, which we are more familiar with, and how we have already started some work here, and how we plan to support startups, SMEs, and also investors in evaluating these startups. So this is through our Sunbird, the support is through our Sunbird drone lab. It's basically an indoor test bed for unmanned aircraft systems, a technical name for drones. And we mainly use it to showcase development trials as well as to customers, so that these startups can commercialize quicker. So the reason we set up this lab right now, it's at the Seletar Airport, is mainly because of this map here, which showcases the different areas in Singapore where it is prohibited to fly within 5 kilometers of an airport, and these drones cannot fly above, say, I think 200 feet. So as you can see, most of Singapore is covered by this sort of prohibition, and that's where the current startups have a difficulty in finding or securing permission to even trial their drones before it goes into a commercial application. And the main area that is available is this area near the Circle Line, where Buena Vista, North, One North, and other areas there. But this area is highly populated with a lot of residential as well as office stuff. And again, safety and security is of higher concern for the aviation authority before they let these startups trial here. And this is a big challenge which limits their testing capabilities. They also lack partners who they can work with to deploy and validate their products, as well as let's say there's an investor or there's a customer for a particular drone solution. They do not have an environment to validate it before they can actually use it or invest in it. And that's where the concept of the Sunbird Drone Labs came in. This, as I said, focuses on smaller systems. These are less than 25 kgs and fly at lower speeds. These larger larger UAS systems are out of the scope of Drone Labs, as you will see in the next few slides where I show the sort of infrastructure we have on hand. So the objective of the Sunbird Drone Lab is mainly to be a one-stop shop for startups and SMEs in Singapore, particularly in the unmanned aerial systems space. The objective is threefold. First is prototyping of new technologies. Second is testing and validating them. And the third is commercializing them through market entry. This is where we also work with investors to help evaluate or due diligence of these startups. The focus areas of how we do this is in three layers. The first layer, we have capability building and acceleration of startups. We basically house these startups and guide them through the process of building their technology. And the second layer is that of testing, certification, development of new technology or products. And the third area is on policy development of benchmarking. So this, we work with either the aviation authority or other regulatory bodies which would benefit directly from the sort of data we collect on how these solutions perform. Now, the UAS sector is divided into four parts. You have air traffic management, you have the vehicle itself, or what we call the drone platform, the data services, as well as training. So EcoLabs mainly focuses on these two aspects of supporting the startups, while we work with our partner at Transport Training College to provide the training and pilot training and those kind of educational requirements. So this is the sort of infrastructure we have in place to support startups in the sector. The Air Transport Training College is at Seletar Airport, north of Singapore. And the hangar here has basically been provided kindly to us by Air Transport Training College to carry out the tests. So this is a picture of the hangar with the previous aircraft that existed. But right now, it's empty and ready for us to deploy some of our testing equipment. There is also a workshop on the top end of this building where we encourage startups to develop new technologies on site, and that's where the one-stop shop model is fulfilled for these startups. In addition, the Air Transport Training College also has an auditorium and classrooms, cafeterias, and office workspaces where startups can actually carry out their development activities without having to travel back and forth from their office in a different part of Singapore. So the core equipment that we have intended to install at the hangar here is mainly application based. So we don't come so much from a technology focus, but we come from an application dictated perspective and try to use that to help the startups develop their technologies. So on the first side, we have weather-related equipment to like say simulating of rain, mist, smoke, and haze, tracking cameras, and communication systems. The key thing that we're looking at here is to solve problems for these sort of applications in logistics, shorter ship deliveries, agriculture, etc. The second area is tunnels. We understand that startups have to go, let's say they're inspecting an MRT tunnel or sewage tunnel. They would need to use a significant amount of time at site when the trains are stopped or when the sewage is completely removed to go and test the solution. So we plan to set up a tunnel section to do the testing here. The third area is on facade. This is for buildings, building survey, window cleaning, and solar panels and those kind of things. So we plan to set up a section of a wall with different cracks, peeling paint and watermarks, etc., to simulate an actual wall so that the testing can be carried out here instead of on site. The fourth area is on acoustics. This is to reduce the noise, which I mentioned earlier. For urban air mobility, one of the key problems is that of noise. And we have an anechoic chamber to help, we are planning to set up an anechoic chamber to help reduce this. Apart from that, we also bring in our expertise on battery testing and improvement. All of this would be set up at the hangar. The objective was to have this launched in June of this year, but due to COVID, there have been a few delays, and probably the early part of next year is when we would have a lot of these infrastructure in place at the hangar. And that's where we are inviting a number of these startups or SMEs to submit certain project proposals so we can factor that in when we are setting up this infrastructure. So in the interest of time, I just have the last three takeaways. First is that we expect these air taxis to be potentially viable in this decade, around 2030. How EcoLabs supports is in two areas. On larger vehicles, we are focusing on core propulsion technology and supporting infrastructure. So we work with either corporates and SMEs to develop this technology, or we work with investors to guide them to the startups which are in our cohort and help them invest or do due diligence on these companies. The third area, which I would like you to take away, is on smaller systems where Sunbird Drone Labs has an indoor testing space. And again, we are inviting project proposals from startups to help take advantage of this infrastructure. You can reach out to me at my email ID, arvindm@ntu.edu.sg. I think some of these slides would be shared later by Sophia and Spectrum. So yeah, feel free to reach out.
Thank you, Dr. Arvind. Would you like to stop share your video? Sorry, your slides, please. Thank you. Can I welcome Ryan back to screen, please?
Oh, I can't start my video.
Okay, just a second, yeah, Ryan. Let me...
Okay, so
right.
Great. Okay.
Probably, do you want me to take the first question that has been?
Sure. So the first question for Dr. Arvind: how will you ensure the safety of many large urban air mobility vehicles flying over the city? Yes,
this is one of the biggest problems. So we start small and we will start with controlled trials. So the larger urban air mobility systems, we don't yet have infrastructure to test them. The intention is to have it tested just outside our current hangar at Seletar Airport. So the airport there is where we are seeking permits to have the controlled testing of these vehicles done before you actually deploy multiple of these across the city. So the core technologies that would ensure the safety is first redundancy in the propulsion systems. The second is providing constant feedback on the state of, like, say, the motor or the battery, the different technologies on board the system, as well as constant communication to the regulatory authority. So they are constantly aware of where each vehicle is flying and what issues it might be facing.
I see. Interesting. So my questions, I have a couple of questions as well. So in terms of Singapore airspace is, busy as it is. So I would see that there's a lot of planning that goes into it. So one of the things that I saw in reports as well is in the design of the air taxis. So probably Dr. Arvind, you want to share more in terms of how the design would look like?
Yes, so in one of the slides, I'd shown the kind of like architectures of these air taxis which are expected. The predominant trend is to go towards this segment of distributed electric propulsion, where you can enable redundancy. So under these, you have basically 5 types of large architectures so far. Uh, the, the, the first one is a highly distributed system, so it consists of multiple rotors. An example of this is the startup called Volocopter. Then you have quadcopters or octocopters, which are very similar to the current drones, like say from DJI. An example of this, a startup doing this is EHang. Then you have hybrid concepts which use a wing as well as rotors. An example of this would probably be Joby. And then you have tilt wing and fixed wing systems, which are being tried by Airbus and even Zipline in its smaller system. So you have like 5 major architectures. It's not yet narrowed down into one, and probably over the next 2 or 3 decades you'll see it narrow down, but right now all 5 seem viable.
So earlier I think in some reports as well they mentioned that the launch of the air taxis is closer than you think it is, but it's also, there's a lot of planning that goes into this, safety, like the challenges that you share with us as well. Noise, we have to ensure that the noise pollution is under control. There's a lot of factors, even signages. How do you send the instructions to the pilot, say for example, to control? Those are some of the challenges that we foresee as well. So probably you want to share with us as well, what are the why the delay? I mean, there's a lot of factors looking into the implementation and the launch as well.
Okay, so from Singapore's context, it's I'll give 2 contexts: the global context as well as the Singapore context. So let's start with the global side. So in the global context, there have been trials already started in places like New Zealand, where regulation has been more open to this kind of technology. So I think as regulators catch up, a number of these solutions will start getting deployed. But safety is always one of the paramount issues, and that's where a lot of the difficulty is. And that's where I will come into the Singapore context, where the first use will probably not be for normal passenger transport. The risk is too high for that sort of a application. Where we might see higher potential is on emergency deliveries or usage by paramedics, where people are willing to accept that risk or accept such noise from such a infrequently used system, just for the sake of protecting lives or saving lives. And that's where the key value would be, I would say, where all these other factors are overridden by a higher requirement, in this case, saving lives. And it's those sort of applications which will take off first before the passengers start settling in.
So we would also look at, affordability as well. So air taxi, say for example, for a normal commuter, I mean, initially it'll be going, the use is for emergency, like you said, and then it'll go towards the use for the normal citizens.
Yes, correct. Yeah. So the reason I'm talking about emergency first is mainly the technological consideration, making sure the systems are safe. In terms of cost, yes, of course, the cost starts becoming viable only when you have mass adoption and sort of shared mobility that Ryan had mentioned earlier. mobility as a service. Some of these have already been trialed, I think, with Airbus in, I'm not sure, I think Brazil, and also Uber's copters. So both of those companies have tried it with helicopters and have started offering services where you can actually go to the airport in a helicopter and cut time instead of getting stuck in traffic. So the economics for a helicopter already seem to be there, and that's the one that needs to be matched by uh, an air taxi. And if that can get kickstarted, then definitely you start seeing increased adoption.
Thanks, Dr. Arvind. So Ryan, my question is on urban planning design. Of course, we have a lot of, shift due to COVID-19. A lot of companies are going into full remote or even half remote and returning later to working in the office as per normal. So maybe I can have your comments in terms of how do you envision the plan for transportation, mobility as a service in the urban planning design?
Well, thank you, Sophia. It's definitely going to be very difficult. That so far, based on my observation, there's largely two schools of thoughts. One group is thinking that because of COVID, the new norm that most people are working from home will be largely permanent. So we are looking at a much reduced need to travel from office to home to office. And the other school of thought is actually thinking that this is just a transition. Over the past decades, we have been through many different types of crises, SARS, and even other financial crises. Economic activities go down, but it go back to normal. So some people feel that we will go back to office in time to come. How I see this is coming from better urban planning, more sustainable city design. What if we look into this from a more mixed-use development? I mean, for the many past years, we developed cities building type based on needs. It's an office building, so people don't stay there. It's a residential building, so people tend not to work in residential. But we do see increasing trends where the building type is being more mixed use. So we have half residential building, maybe another half of commercials, or maybe half office building, the other half commercial. If you are able to redesign this where maybe the top level would be residential, followed by some office or even a Soho concept, then with residential, we actually have the opportunity to reduce the need for people to commute on a daily basis. Of course, there will be time where we want to go to the Orchard Road. Maybe you want to go to Ubin or somewhere else. But if we reduce the daily commute to within 2 kilometers, this will bring traffic, potential traffic out on the road. So this will increase the commuter experience. The vehicle can move faster, there's less congestion, there's less traffic on the road, also means that there's less likely accidents can happen. Less people in the public transport also means that the experience for the individual commuter will be much better. So with that, if we can redesign the urban planning with that in mind, mixed-use environment, the overall efficiency and sustainability will increase. So that's one way to move forward. And we are seeing this happening in the Tengah residential area. We are seeing this in the Jurong Innovation District in Singapore. But again, urban planning is very high on the infrastructure side. That's also the limitation of existing city. They are unable to change their infrastructure to drastically because of the area they built up. There will be a lot of inconvenience to the city planning.
Thanks, Ryan. So this question from an anonymous asked about the MaaS model, merge public and private solutions. I believe it's the payment systems that you have to work with a private solution provider. Am I right to say that? Ryan?
Okay. Yes. So it in terms of merging the public and the private solutions, it's really not about merging them. It's really to bring them into a single platform. So, for example, um, let's say I take the time five years, maybe 3 years ago, for example, I will have one app to book a taxi, one app to book a Grab, one app to book Uber, the shared bus. Then if I need to check the transport solutions, I need to check download LTA app. So I need to go through different uh, channels to do a simple thing, just for me to travel from point A to point B and actually getting me there. But if we have a integrator, a single layer on top that's customer facing, so I can get all my journey plannings needs done from there, selecting which route, proposing which route that I prefer. It could be the cheapest, fastest, or even I just want to get there in the most comfortable way. So I can choose that, and it will deal with all the booking, planning, booking payments, and even in some cases locking and unlocking of the vehicle. Let's say I take a shared vehicle. So this single user interface will enable me to increase my user experience as a commuter. At the same time, the mobility service provider can focus on their functionality, their operation, their fleet management, instead of spending the time, the effort into managing clients, managing customer, getting customer to go on board and so on. So there will be a cost saving across the whole value chain.
Great. Thanks, Ryan. Dr. Arvind, do you have, can we answer this question? I think it's a good question as well. Is there any research being done into the possibility that urban air freight will open up a possibility of aerial pirate drones, and how would this be mitigated?
Yeah, can you hear me?
Yes.
Okay, yeah, I think that's a great question. I don't think there is any research being done into that. Definitely a big thing to look into. Right now, the only way to mitigate it is to have a tracker on your package. So you know, even if the aerial pilot drone has stolen it, where the package is off to. So it's kind of not a very active way of handling the situation. It's just a passive way. But yes, definitely a big concern, but no research that I'm aware of.
Right, thank you, Dr. Arvind. So I think I'll round out this session with just one last question, maybe a quick one, Ryan. Which of the existing modes of transport are the most likely to disappear first?
Okay, this is tough. I personally believe that private vehicle, in terms of market share, they will reduce a lot. Maybe I didn't explicitly mention it in my presentation, but I believe that in the future, with the rise in autonomous vehicle, there's no need for there are essentially no needs for private vehicles. So as long, let's say we have a pool of 10,000 autonomous vehicles in Singapore, through a mobility as a service app, I can actually book a vehicle that comes to me anytime through an autonomous vehicle and pick me from places to places, however time it is. So it essentially is a level up from car sharing, but even more exciting, because with autonomous vehicle, just like the video I showed, the vehicle can actually pick up goods or even people anytime, anywhere. And with that, it gives user more flexibility. If I need to drive a vehicle, I need to go look for parking, I need to spend the time and energy to drive to make sure that I get the direction right and ensure my safety and so on. With autonomous vehicle going along, coupled with mobility as a service, I would say that in the future, driving is really a luxury and really a choice that you consciously make a decision for. It's really for people to have fun. It could be like a hobby to people instead. And of course, autonomous vehicle may not meet the needs of all type of commute. There will be some cases where cycling, e-scooters, or other type of transport modes will be relevant.
All right, thank you so much, Ryan. Thank you, Dr. Arvind from EcoLabs Center of Innovation for Energy. Really thank you for your time today, for the insightful sharing. So thank you, audience. So join us next week for the webinar on She Economy, where we'll focus on women as the biggest drivers and beneficiaries of new business models in the internet economy. So when you exit this webinar, please help us to answer the feedback form, fill up the feedback form, and we'll see you next week. So thank you again, speakers. So I'll see you. Stay safe and keep well. Thank you.
All right.
Bye.
Thank you. Bye-bye.
Bye-bye.